Today I will talk about log rank test. This is one of my three lectures on survival analysis. It is part of biomedical statistics. This is my lecture outline. First I will give introduction, then I'll talk about assumptions of log rank test. Then I'll talk about null hypothesis of log rank test. Then I will derive the formula of log rank test. Then I'll talk about extension of log rank test. Then I'll describe Python code with one of the Python package how to calculate the log rank test. Log rank test is the most commonly used statistical test for comparing the survival distribution of two or more groups. So this is the survival curve of astrocytoma, which is one of the brain tumor, and glioblastoma, which is another brain tumor. Glioblastoma is known to be more aggressive. So this I have taken from this article. The survival of glioblastoma is lesser as compared to survival from astrocytoma. So log rank test is a non-parametric test. That is, it does not require us to know anything about the shape of the survival curve or the distribution of survival times. In log rank test, we calculate the expected number of events in each group, that is expected in first group and in second group, while observed in first and second group are the actual number of observed events in each group respectively. Then we can use either standard normal distribution or chi-square distribution to assess the statistical significance. The idea behind the log rank test is essentially the same as that of the Cochrane, Mantel, Hansel test in categorical data analysis with time as the stratification variable. Assumptions. The log rank test is based on the same assumptions as the Kaplan-Meier survival curve. These are the assumptions. First assumption is that censoring is unrelated to prognosis, or the probability of censoring should be the same for all individuals within each group. The survival times or event times of individuals in each group should be independent to each other. The hazard rate, that is the risk of an event occurring for the compared group, should be consistent over time, or the survival probabilities are the same for subjects recruited early or late in the study. This concept is known as proportional hazards. The events happened at the time specified. So these are the assumptions of Kaplan-Meier survival curve. These are the assumptions for log rank test, and these are the assumptions for Cox proportional hazard model. Null hypothesis. So null hypothesis is that there is identical cumulative distribution function or cumulative density function, or identical survival function, or identical hazard function. An alternate hypothesis is that null hypothesis is not present. Derivation of formula. Assume that we have two groups of individuals, say group 0 and group 1. In group J, there are nj independent and identically distributed underlying survival times with common CDF denoted by capital Fj for J, 0 and 1, because we have two groups. The corresponding hazard and survival functions for group J are denoted by Hj and Sj respectively. The survival times are denoted by this symbol. The information at time I can be summarized in the following 2x2 table. At event time I, in group 0, there are D0I failures, and these are individuals at risk. In group 1, there are D1I failures, and these are individuals at risk. And this ratio can be viewed as an estimator of hazard function at this event time. Since D1J has the hypergeometric distribution, the mean and variance of D1J under null hypothesis are these. I have taken from this website resource. we defined as observed event at I is equal to d1I, then Fisher's test would tell us to consider extreme values of d1I as evidence against H0. And if we defined as observed event, expected event, and variance as summation of these values over the or over all of the event times, then Z, which is defined by observed minus expected divided by square root of variance, will follow normal distribution with mean 0 and standard deviation 1, that is standard normal distribution. And its square of this statistics will follow chi-square distribution. So we can use any of these to assess the statistical significance. Extensions of log rank test. Stratified log rank test when we want to control or adjust for a categorical covariate, example gender. Weighted log rank test when we want to emphasize certain times more than other times. Log rank test for more than two groups when we wish to compare the survival distribution of several groups. Log rank trend test when we want to test for a trend in the survival function or hazard function in the p plus 1 groups. For example, if the groups have a natural ordering. Now let us see the weighing scheme of weighted log rank test. One of the scheme is according to number of individuals at risk at time t, that is nj. The other is according to pooled survival estimate. This is the pooled survival estimate. And this is to note that both tests place more emphasis on earlier failure times compared to the usual log rank test. Then Python code. I will describe Python code for log rank test using the Lifeline package of Python. So we import log rank test and we use the data test, which is inherent in the Lifeline package. So we load the dataset. Dataset have three columns. First one is time duration. The other is event, whether it is censored or not. And the third is group, in which group the particular individual is in. So the groups are control group and this 137 group. So these are two groups. We have split the data set into data set 1 and data set 2 between these two groups. Then we use the code log rank test as this to get the p-value, and this is significant in our case. And the test statistics is, which is the chi-square test, is 122.249 in our case. Then this is log rank test for more than two groups. The package is same, Lifeline, and we import multivariate log rank test. And this is the data frame. It has the first column as time duration, second column as event, whether event happened or it is censored, and the third is group label. This is how we execute the log rank test. And this is the result. And p-value is not significant in our this hypothetical data set. Then this is the pairwise log rank test. Package is same. We import pairwise log rank test. This is our hypothetical data. And this results in pairwise differences between group 0 and 1, and between group 0 and 2, and between group 1 and 2. So these are the respective p-values. This is all for today. Thank you very much.